Okay, last video. I don't know if these are working very well. The sound keeps messing up, so at least you can watch me fill all this stuff in, even if you can't hear me. Okay. Explain and predict the motion of a body in absence of a net force and when forces are applied. That's kind of confusing. Okay. Okay, so we've got these three scenarios here. In the first scenario, we've got forces exerted in opposite directions. Okay, so this is 10 newtons to one side, 10 newtons to the other. So this is going to be a balanced scenario because we've got 10 minus 10 is 0 newtons of net force. So this might be an object that's at rest, okay, or an object that's in constant velocity, maybe. I don't know. This object has got two forces, both this way. So we're going to have 10 newtons plus 10 newtons is 20 newtons to the right of net force. And then this object has got 10 newtons to the left and 8 newtons to the right. So I'm going to have 10 minus 8 gives me 2 newtons to the left of net force. So I'm just using vector math on those to come up with values for the net force. Net force meaning the vector sum of my forces acting on my object. Okay. Okay, truck is traveling at a constant velocity. Okay, so we talked about that today. What must be true of the forces acting on the truck? They are balanced. These are balanced forces. Are there forces acting on the truck? Yes, but they are all balancing each other out. So there's no net force value because the truck is not accelerating. Okay. Motion graphs for net force is equals 0. That means balanced. So that's going to be things like position versus time where I'm at rest, or position versus time where I'm in a constant velocity, or velocity versus time where I'm at a constant velocity. And then for unbalanced, it's going to be things like position versus time with a curve where I'm accelerating, velocity versus time where I'm accelerating. My velocity is changing. Okay. Okay, mass is a measure of inertia. What does inertia mean? This is our tendency to resist change in motion. So if we have more mass, we have more inertia. Which cart has more inertia? This is kind of hard to read, but there's two boxes here that total 34 kilograms for cart A, and then 12 kilograms for cart B. So cart A has more mass, so that means it also has more inertia. Okay. Okay, and then the last one, we're going to rank some accelerations. So we're going to figure out the acceleration of each of these boxes. So okay, so we've got 9 newtons minus 3 newtons is 6. 6 newtons divided by 2 kilograms gives me 3 meters per second for box A. C is 9 minus 3, 6 newtons divided by 3 for the mass gives me 2 meters per second. This one, 6 newtons divided by 2, again is 3 meters per second. So I'm just taking the net force, whatever that vector sum is, and dividing by mass. Okay. Here I've got a force of 9 newtons divided by 3 gives me 3 meters per second. Here I've got 3 newtons divided by 3 for my mass, 1 meter per second. And then I've got 6 minus 3 here, which is going to again give me 3, again divided by 3, 1 meter per second. So if I ranked these, my greatest accelerations are A, E, and B. They're all equal to 3 meters per second. And then those are greater than C, which is 2 meters per second. And then C is greater than D and F, and they're equal to each other. They both have 1 meter per second per second. Okay, hopefully those are helpful videos.